In this lecture, we'll be talking about the characteristics of the bonding and anti-bonding and how we're going to fill the bonds of the MOD and all that we were discussing in this lecture. So first of all, you have to assume a formal assumption of the formation of these bonds that are probably AO that is created here at the sides. AO basically shows us the atomic orbital in which there can be 3p, there can be 2p, anything that is related to orbital or any orbital can be assumed to be taken. Here the AO, the nucleus of one atoms are making bond with nucleus of another atom, while this section shows us the bonding of that formation. So how they actually make the bond, why there is pi bond, why there is sigma bond. So this all is discussed in MOT. Now here at very initial, these two are called AO while these are called MO. This is also called MO, that is molecular orbital. Here word molecular shows us that there is formation of a molecule, because we know that whenever two atoms join, they probably makes a molecule or a compound. So here this section is known as anti-bonding while this section is known as bonding. Now here this section is known as anti-bonding just because it has higher energy level, as we discussed in our previous lecture that there are two types of bonding, anti-bonding and the bonding that is lower energy level. So here you can see that there is formation of the anti-bonding and bonding. While on the other hand, just assume that we do have two types of bonds and there are 16 electrons. So how many like lone pairs would be there? How many pairs would be there? This all is discussed by the formula of bond order. We can find out that how many pairs would be there, how many lone pairs will be there. So this all can be done by the bond orders formula, that is Na plus N2 NB, divided by 2. Here Na shows us the molecular orbital of antibonding, and where NB shows us the molecular bonding of the bonding orbital, that is divided by 2. So we're going to do that with example 2. So here just suppose that we are talking about the hydrogen atom, while we do have one electron from here and one electron from here. So this is the bonding, this is the anti-bonding. Now keep that in mind whenever we are filling the electrons. First we have to fill in the lower side, the lower energy level. So let's fill the lower energy level. Now here we do have one electron here, total electrons 1 plus 1 is equal to 2. So it's clear to you all that there would be only 2 electrons. So we have to make pair as according to the Hund's principle, because we discussed in previous lecture that this all focuses on Hund's principle, Pauli rule and upward principle and all that. So according to that, we have to fill it in the form of the pair with opposite spins. So we have filled it likewise. Now we are out of the electrons because there were 2 electrons and we have filled the 2 electrons. So here let's see that will that bond order will work or not. So let's put in the formula, that is Na plus Nb divided by 2. Here we know that the Na, that is probably here, it consists of 2 electrons, while the Nb here consists of only 0 electrons. So we're going to divide it by 2. So 2 plus 0 is equal to 2, and divided by 2 it will be 1. So here you can see that the answer is also 1, and we do have only one pair of electron. So this is how this formula works. So let's move on to another example so it will be clear to you all. Here we do have another example of a atom, that is probably the nitrogen. Now we know that nitrogen, we have 5 electrons at this side, 5 electrons at this side, Total we have 10 electrons. So here I have filled the electrons accordingly. So you can count it here. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now here you can see that here we have filled it in a form that is unpaired. Why there is so? Because we know that we are only left with 2 electrons. So in that condition you have to fill it at the same spin with an type of a separation. So let's put in the formula. That is, we know that in the antibonding area we do have 8 electrons. That would be added in 2 electrons. So we do have 2 electrons here. So it would be divided by 2. That's equal to 10 divided by 2. So so we created a problem in the formula. Here it's not positive, it's negative. So our answer would be 6 divided by 2, that is equal to 3. So here you can see that the bond order is also 3. So this was how we fill the forms and all that. So I hope that you get it, and thank you so much for watching the video.